name is Renee Ulsch from Alray Automate, and today I would like to show how you can easily program the universal robots with our programming flange. There are two ways to program. We have a programming flange that you can screw directly to axis 6, or alternatively there is this handheld that you can simply screw to the torch holder with magnets for programming. It has the same functions at first. The only difference is that we use this model for all TIG applications and plasma applications due to the high frequency ignition and the flange directly on axis 6 screws with the high frequency ignition. There are problems because we pass the signals directly through the robot and we can get interference frequencies here. In the MAG process, this is not a big issue, so here we are now. The Lefinus system attaches the programming flange directly to the robot axis 6. The programming flange here has a small light string at the top, is connected directly to the cable to the axis 6 of the robot, and has 3 buttons here. We have a button for the trial, a button for the free drive, and another button for setting W points. To efficiently operate with the programming flange, UA caps are utilized. These specialized caps have been engineered for various subjects. Onboarding involves the use of the T-trolley, then I reveal the split screen, virtually select the UA cap, and can immediately generate a line in the robot by pressing the waypoint button. I always get a little feedback directly through the light ring, through a little flashing. You may have seen it briefly, it lit up briefly, and we can see directly here. The robot itself has written a program point in the driver axis. Free space 0, we move slowly to the component. There are sometimes different clamps or geometries around which we have to drive around to get the welding position. So I'm now setting a starting point. I press W6 again, and we see in line 6 that we have occupied a new free point. I then move the robot, as any welder would do, to the position I want to weld, and here I press Activate Process. We now see a red light, which means the robot would activate the process here. In the robot program itself, we see welding in line 8 with the communication to the power source. The robot would now say something to the power source, OK me. Activate the process and then independently change its operating mode. Into Farah P. We see that here Farah P weld, that's the point. We then guide the robot to the end point of our weld seam, and at this point we can directly deactivate the process again. The red light goes out and we see that the robot has a point process here, line 12. Welding has a point here, and after that, welding makes up. We can now lead the robot away, set a landing point again. That's exactly driving away. And that's the simplest form of programming with a very simple barcoder. I can now deactivate the programming here. We see that the green line has basically gone out. We program active age, and if I now press play, I want the robot. Even while navigating to the initial point, I can initiate the process, and the robot will begin executing the welding task. Currently, I am just running a simulation. The origins of the velocities are now visible on the interface. These include velocity sweat, clearance velocity, and velocity 2, measured in millimeters per second. Degrees per second measure free space, and I can alter this anytime if I wish for faster welding with increased power. This represents the most straightforward method.